Okay, apply sine and cosine rule to find sides and angles of non-right triangles and some other area formulas just for fun. So, as that suggests, we're going to be dealing with triangles that aren't right angle triangles, which I told you before, don't use trig on non-right angle triangles. But turns out we can fiddle around with the rules a little bit so that they're still useful. So, sine rule is 4f, cos rule is 4g, the area stuff is in 4h. Beautiful, okay. Well, first of all, I better explain what's going on because we've got a whole lot of rules and symbols. Okay, first things first, A, B and C, they're just side lengths. You are free to choose whichever side you want. It doesn't matter about so A square, B square, C square. You have to have C as the longest. In this, doesn't matter at all. You're free to choose whatever you want. And I so choose as this because I said so. Okay. The next bit is the alpha, beta, gamma. They always go opposite their matching letter. So opposite A will be alpha, opposite B will be beta, and opposite C, gamma. Okie dokie. So that's the naming convention. Remember that this could have just as easily been B, C, A, or any other combination you wanted, just the opposites should always match. Fantastic. All right, well, we want to figure out some stuff. Let's say we wanted to figure out theta here, okay? Well, we could do a very straightforward thing. We could go, well, hang on, this is 40, this is 60, therefore this must have been, where are we going to put this? Put it in red. So this must have been, what, 100? Sorry, 80 rather. Jeez, that was a good start. 80. Okay, fantastic. Now, just to make sure that that wasn't a problem, we'll put this into our equations. So we get, okay, sine of the thing we're interested in, alpha, over, in fact, actually I'll put theta, because that's what we're actually calling it. Cool, over A, which was our x length, equals, oh no, we can't do this, sorry, forget that. Sorry, we can't do that because then we'd have two unknowns in there. So the only way we're going to make this work is if we've got theta already. So that's fine. Okay. So we've got 80 in there, great. Well, let's say we now want to figure out the side length that goes with it. Okay, so we've got side length of, sine of alpha being 80 over side length A, which is variable x, plus, and I'll have to move that C out of the way, no, plus, equals sine of. Now, we could try to do this, but then we'll have y in there, then we've got two variables, then we're stuck, that's no good. So what I want is the side that actually has a complete set. That'd be 40 and 12. Fantastic. Okay, from there, we could do this step by step, but I'm going to do a whole lot of things at once. I'm going to do as follows. Sine of 80 times by the 12, and then divide by sine 40 equals times by the x. Done. You're welcome to pause for a second and just double check that you can get there algebraically. From that, we get some terrible number. I have no idea what it is. Sine of 80 times 12 divided by sine of 40. Gives me 18.385-ish. Therefore, x roughly equals 18.385. Is that what I said? 18.385. Yep. All right. And again, you round wherever the question tells you to round. Cool. All right. Well, that's all well and good. What about this cos rule instead? Well, just for a little bit of giggles, let's say instead we wanted to figure out y, we're going to do it with a bit of style, so now we're going to figure it out with cos rule. Okay. Conveniently, I've already got that labelled in the correct way, such that C is the subject there, but this is some of the best stuff about the sine and cos rule. You can fiddle with the orders as much as you want, so long as this first one and the last one have to be opposites. Everything else has to be the other sides. So I've got C here, that goes with gamma, so those are your bookends. I've got A, B, and then A, B again. If I wanted this to be A, then this would be alpha, this would be B, C, this would be B, C. Since this is adding, it doesn't actually matter if you go A, B, or B, A, and since it's multiplying, it doesn't matter A, B, or B, A. All that matters is these two are repeated again, and this is with its opposite. So, off we go. C squared, so that's y squared, equals A squared, which we had up here. Since we're approximating, I'll turn that into a rough equals. 18.385-ish squared plus B squared, 12 squared. We'll put it in brackets and say that we sub that in. So, minus A, which we had before, 18 point garbage, times b, which was 12, times cos of the angle that goes with that, which would be gamma, so 60. Fantastic. This is going to be an approximation. So let's go for last answer squared plus 12 squared minus 2 times last answer times 12 times cos 60. Bang, gives us 261 and some change. 61, 3898, oh that's a lot of them. Alright. 389, then I'm going to put dot dot dot, even though that would round out. Let's put dots. Beautiful, okay, great. Well, hang on, we haven't square rooted that, so square root last answer, 16, 16-ish. Is that what it was? Yep. And again, that should round differently, but that's fine. Beautiful, so we've got that side. It's usually a good idea to check if these side lengths make even a remote deal of sense. Well, this side is 12, and that's got an angle of 40, so that's a pretty tight side. So this should be the smallest side out of these. This one's got an angle of 80, so that should be the biggest. 60 should be somewhere in between. So somewhere in between, 16, biggest 18, smallest 12. Yeah, that makes sense. These are all reasonable angles. None of them are super tiny or super big, so these should be not terribly dissimilar numbers, and they're all in the teens, so we're happy. Fantastic. Well, I want to figure out some more stuff about this third triangle. So I'm going to get the area. I'm just going to write capital A because I can't be bothered writing area. Okay, that's a half times A. A we had before, which is now X, but same thing. So 18 point garbage, 385-ish, by B, which was 12. And then sine of the side that the angle that we didn't use, which was 60. So with this, again, you can make a whole lot of shifts. If I've got A and B, the angle is the one that does not get used in here. So AB and C's angle, but you could just as easily have BC and A's angle alpha, or the other version as well. Fantastic, great. What do we have? Where's that 18 number? Scroll back up. 18 number times by 0.5 times by 12 times by sine 60. 95.5-ish. Nice and easy. Fantastic. Well, what's this monstrosity down at the bottom? It's another way of figuring out area. Now, you might go, well, hang on, this purple one's nice. Why can't I just use that? And the short answer is, well, yeah, you would if you could. The difference between these, this is when you've got two sides and an angle. This is when all you've got is three sides. That sucks. But you can still work it. So you've got S, A, B, and C. S is new. It's what's called a semi-sum. All it is A, B, and C, so your perimeter, divided by 2. So the sum, and then semi, half. So half the sum, hence semi-sum, hence the S. Okay. So, new area, roughly equals. Now, we can't do that because we need to know what S is first. Good job. S. So, we've got A, B, and C. What was 18 was... Well, we're going to add them all anyway. So, 18 was Y, which was C. Add the 16 one, add the 12, and here ends up then divide by 2, because you don't want to just divide the last thing by 2. 23, 27, 6-ish. 23, 27, 6-ish. Fantastic. Then area will roughly equal, woo, this is going to suck. Alright. 23 and some change multiplied by 23 and some change minus the first thing, which I'll just put in 18 and a bit, times by 23 and a bit minus whatever the other one was, 16 and a bit, and then 23 and a bit minus the perfect 12, done. Now for the best bit, you have to type the bloodies in here. Well, that's unfortunate, but suck it up, you can always scroll up to get perfect, well, as close to perfect as possible. So 23 multiplied by this thing. So last answer minus the 18 number. It's up here somewhere. 18 number, close bracket, open bracket. Last answer minus the 16 number, which is there. Close bracket, open bracket. Last answer minus 12. Cool. So that's everything under the square root, then I want to square root that, square root the last answer. So that roughly equals 95.53. Look at that magic trick, they agree. Almost as though math is consistent or something. Fantastic. So, like I said, this one is almost always easier and more straightforward. Having said that, if the side lengths are all integers, this actually ends up being a bit easier. But horses, courses, you do what you need to do upon seeing it. So that all looks nice and easy and boring, so why have I bothered with another triangle? Well, isn't that a lovely question? Let's try some things with this. Now, specifically, do I need to label this specifically? No, that's fine. A, B, C. Okay. I am particularly interested in this angle for this particular question. Okay, well, let's try sine rule. So this would be alpha, this would be beta, this would be gamma. Okay, so I'm going to have sine of theta equals sine of 30 over 10. Right, and with a little bit of stuffing around, we can figure out sine of theta equals 8 times sine of 30, that's a 30, over 10. And, yeah, we'll write that down. That's a half, so that's 20, 8 on 20, what's that, 4 on 10, 2 on 5. Cool, we want to get theta though, so sine inverse of 2 on 5 will equal theta, and that'll give us some terrible number. Sine inverse 2 on 5, 23.578. 23.578, and some change. Okay, fine, well that seemed easy enough, until we look at it and go, wait a minute, 23, that should be an acute angle. What happened here? Well, there's a couple of problems. Not least of all is how it's been drawn. Well, hang on, if this is 10, how is that possibly 8? Right, so this is where we're going to be a little bit careful about how drawings happen. Okay, fine. So this drawing should actually look more like something like that, where this is 8, this is 10, there's your theta, there's your 30. All right, well, that now solves that problem. Fantastic. Okay, well, that's all well and good. I want to fiddle with this a little bit more. Okay, what if instead we had, okay, this is going to be 8, this is going to be 10. All right, well, that's fine. Now the picture actually looks reasonable. All right, get rid of this guy, and we need to reset this. Okay, same story, we can still try and use sine. So sine theta over 10 this time equals sine 30 over 8. Okay, not a problem. Fine. So we get sine theta equals sine 30 multiplied 10 over 8, which will give us half 5 on 8. Sine inverse 5 on 8 equals theta, which will roughly equal some crap number. Sine inverse, what was it, 5 on 8? 5 on 8. 38,682. And lo and behold, hang on, we've got that same problem again. This is supposed to be an obtuse angle. That's an acute. That can't be right. Or can it? Well, I bring to your attention the possibility that this has happened instead. What if C was a lot longer than this picture was a lot longer than this picture illustrated? Because this could still be 8 going out that way. That's fine. In which case this angle would have been 38.682. But hang on, this one here, that should also be a valid triangle. Because this is longer than that, that's fine. There's no problem with that. Why is it not giving me this option as well? That's a little bit weird. Well, we can kind of cheat a little bit and say, hang on, this side and this side have to be the same. But if that's true, then this angle has to be the same as that angle. And that we've figured out is 38 point, etc. So this must be 180 minus that 38. So we're hoping, what do we get, 141.317-ish. So that's our belief at this point, that that could be that. Well, that's irritating because now we have to think, whenever you use the sine rule, there's this possibility that it doesn't give us this other version of the thing. So you have to always be careful about the drawing. Well, what about cos rule? Does he suck or is he okay? All right, let's think about cos rule for a second. I'm going to change the way it's written because we want theta, which is alpha. Currently it's set as gamma. Well, alpha goes with a, so I want a squared equals b squared plus c squared minus 2bc times cos of this guy's angle, alpha. So that's what I'm using. Okie dokie, well, we can sub stuff in. 10 squared equals b, which was 8. Oops, that's terrible, 8. 8 squared plus c squared. Oh no, we don't know c squared. Okay, 2 times 8 times we don't know, times cos of, did we have angle alpha? No, that was theta. And what we notice is cos won't give you the wrong answer. It'll say, hold up there, champ. I need to know how long this is, because I need to know if it's this short one or this long one. So cos will never give you an ambiguous answer because it won't work. It'll immediately go, good job, I need more information. Sine will go, yeah, okay, and just run with it. Sine will always give you the version where it's an acute angle. Conveniently though, we can run that trick always. It will always be, the two possible angles will add up to 180 because of this argument that we ran through before. So if you use cos rule, you don't have to worry about anything. It'll always work if it's valid. If it doesn't work, then that's telling you you've got potentially an ambiguity or you've just plain old stuffed up. If sine rule works, just take 2 seconds to think, hang on, is there another way of drawing this triangle? So that's the ambiguity of that. We'll run through exactly why it comes out ambiguous when we do a little bit more stuff, but for now, it's just something to be aware of and wary of. So that's for F, for G, for H. Best of luck to you. Cheerio.